know how to record and I know how to use it. All right, so I'm recording, so we're going to keep the vulgar language to a minimum. Okay, so again, if I had to multiply, if I had 9/8 and I want to multiply by something and I want to end up with 8a on the bottom, I want to go from 8 to 8a, I'm going to multiply by a special a over a. Don't even care what a is. All right, I now have 8 times a is 8a. On top, I have 9 times a. So certainly, if I had 5, 6, and I was asked, okay, what am I going to multiply to get an 18 on the bottom? How do I change 5, 6 into something over 18? Well, I'm going to multiply by a 3 over 3, 1. 3 times 6 is 18. 3 times 5 is 15. I now have 5 6 in the form with 18 as the denominator. What if I wanted 5 6 with a denominator of 24? 5 6 times what equals 24 on the bottom? 4 times 6 is 24, so I'm going to multiply by a 4 over 4, 1. And I get 6 times 4, 24, and I get 20 on top. I think they do the example in the textbook where they say take 5 6, give me a denominator of 42. How do I change 6 to 42? I'm going to multiply by 7. If I multiply the bottom by 7, I must multiply the top by 7 because multiply by 1, the value does not change. 6 times 7, 42, 35 over 42. All right, now, since 35 over 42 equals 5 6, we know that there is a 7 over 7, 1 in these factors. All right, so let's take an example on how we're going to use this information to be able to simplify fractions. If I have 12 over 18, and they say simplify, that means they want it in the lowest reduced form that at least one, so it cannot be reduced anymore. Okay, so the way we do this is where all that factoring that we did in section 3.2, the factor tree, blah, 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 this is where this comes in. 12 is 2 times 6, which is 2 times 3. So 12 is 2 times 2 times 3. And 18 is 2 times 9, which is 3 times 3, 2 times 3 times 3. Now it's very, very easy to reduce this in the simplest form. 2 over 2 reduces to 1. 3 over 3 reduces to 1. So I've got 1 times 2 times 1, I have 2, and I have 1 times 3 times 1, I have 2/3. So 12/18 in reduced form is 2/3.
You're real foggy. I can't see your numbers. Could you do another one of those? And
I will do 2 more of those because they're fun.
Okay, and you're foggy.
Okay, I see
you're out of focus.
Okay, you're saying that my camera went out of focus.
Yes, you can't see your numbers.
Okay, let me. Normally, if I wave my hand in front of my camera, sometimes it still looks foggy for me. Not foggy, blurry.
A little pixelated for me.
Yeah, I can't see your numbers. There, that's better.
Better?
Yeah, that's good.
Okay. Yeah, not sure why this camera does this. This is a document camera, and it does every once in a while lose focus. And so typically I just wave my hand in front of it and then take it back and it will autofocus. Did it just go out of focus?
Yes.
Okay. I have another a laptop set up here, and what I do with that laptop is I enter the class as a guest in my own class. And most of the time, if I'm not too excited about what I'm doing, I look over and verify. Boy, she's doing poorly now, huh? Still blurry?
Yes.
Let me switch to the back to the other camera for a second and then see if that will force it to, she's trying to focus.
Oh, good. That's good.
Much better. All right. Yeah. And if that happens, yell at me, because if I'm doing something, I don't tend to look over and see what you guys are seeing, and this is being recorded, so I want to do it right. Okay, let's do another one here. How about -8/20? All right, so I'm going to reduce this. So 8 in factored form will be negative either on top, bottom, or in the front. We can put it in the front. And so I need the factors of 8. 8 is 2 times 2 times 2. And 20 is 2 times 10, which is 2 times 5. And then we got to keep, because there's one negative here, we've got to keep a negative in our answer. So now, what's reducing out? Well, 2/2 is equal to 1. And 2/2 is equal to 1. So I have 1 times 1 times -2 equals to 2, and 1 times 1 times 5, and I need to carry this negative, either on top, on the bottom, in the center. It doesn't matter. The answer machine, the software loves any of those answers. If you want to put it up on top, great. If you want to put it down on the bottom, great. You put it in the front. Call it the opposite to 2/5, that's fine. All work wonderful. All right. More. Yell again if the green starts to fade out on, sometimes the green doesn't show well. Here we go, 20/35. Now, some students, once you've done a bunch of these, you might look at that and say, I know there's a 5 in top and bottom. All right, so I am going to take this and make this 4 times 5 over, what is it, 7 times 5? All right, and so now I have 4 times 5 over 7 times 5. The 5s are reducing out, and I end up with 4 7s. That will give the exact same answer as if you did the entire factoring. 20 is 2 times 10, which is 2 times 5. Why did I cross off? No, that's right. 20 is 2 times 2 is 4, 4 times 5. Yes. What did I do? Oh, that's right. Okay. And then 35 is what? 35 doesn't go by, 35 is going to be 5. 5 times 7. That would be the factor tree, or the step factoring. Okay. And you're going to get the same answer. The 5s are going to reduce out, and I'm going to end up with 2 times 2, which is 4/7. All right. But again, as you start to see a pattern on top and bottom, lots of times students will find shortcuts that are very, very valid, perfectly wonderful. All right, let's do something with a variable in it. We'll do a real simple one. If I have 4x over 15x, when I factor that, I can say this is 2 times 2 times x, or it is just 4 times x. And the 15 is just 15 times x. And x over x, anything over itself is automatically 1. This is going to reduce to 1. And so I just have 4/15. And a lot of students will see that. If I have 9/10a, they will say, the only thing that's going to come out of here are the a's. And that would be 9/10. All right, let's take one that is a little more effort. I'm going to do 90/84. All right. Now, I'm not sure what's coming out of here. I know a 2 is coming out. Maybe more. 90, factor tree, 2 times 45. 45, 2 doesn't go into it, 3 does. 3 and 15, and 3 and 5. So this is 2 times 3 times 3 times 5. 90 has been factored. 84, same thing. 84 comes out 2, gives me 42. And 2 gives me 21. and 3 gives me 7. 2 times 2 times 3 times 7. All right, now, once we have it factored, it becomes very easy to finish the reduction. The 2's reduced down, one set of 3's reduced down, so I'm left with 1 times 3 times 1 times 5 is 15. And on the bottom, I have 1 times 2 times 1 times 7. 2 times 7 is 14. So 90 over 84 reduces to 15 over 14. All right. Now again, you could have done 2. You know, a lot of students would say, I see a 2's coming out, and so I'd take and I'd have 45 over 21, and then they'd say, well, what else can come out? I guess a 3 can come out, and so divide by 3, I end up with 15 over. This is a 42. Take out a 3, and I end up with 14. You could do it that way. This is going to be a lot less confusing and a lot more secure. When you're starting to do it in pieces like this, and most of us do, most of us, after we've done a couple hundred of these, we will look in pieces. And I will show you some that we do in pieces, make it easier. All right, we'll do one more example of this, up to where you will find the factors, use the factor tree. Once you have the factors, it just reduces itself. 105 over 135. Now you can do the factor tree, or because I've done this several hundred times, I look and I see, well, there's not a 2 coming out. Is there a 3? 5 plus 1 is 6. 3 comes out. 3, 105 divided by 3 is what, 35? So 35 has what, a 5 times 7. On the bottom, 135, 5, 6, 7, 8, 9. Then the sum is 9, so I know a 3 comes out. 135 by 3, 12 gives me a 4. 45, 45, a 3 comes out of 45, gives me 15. 3 times 5. So I use the factor tree to factor this out, and I use the factor tree to factor this out. So I've got 3 times 5 times 7 over 3 times 3 times 3 times 5. What's going to reduce out? So it becomes simplest. These 3's are reducing out. These 5's are reducing out. So I'm left with 1 times 1 times 7. And 1 times 3 times 3 times 1. 3 times 3 is 9, 7 ninths. So 105 over 135 reduces to 7 ninths. Now, if you watch the videos, they use the term cancellation. And I have always hated that. I've argued with some textbook authors. They told me to go away. The term cancel means it goes away, right? I mean, if a meeting has been canceled, it's not there anymore. It's gone. It doesn't get postponed. It's gone. So to me, the term canceling is terrible. But the world of chemistry, when they reduce like this, they're saying, those 3's are gone. They didn't really disappear. They turned into 1, and then 1 times anything is still itself. So they use the term cancellation. And so the world of chemistry has kind of slid into the world of mathematics. So a lot of times, and like I said, I watched a video on this, and they call it, they cancel out. They say these 3's cancel and these 5's cancel. But they don't turn to zeros. That's very dangerous. Lots of students hear the word canceling and they turn those to zeros. And that becomes, wrong. Very, very bad deal. Okay, so they reduce out. The textbook in the chemistry world calls it canceling. I fought with them and lost. So if you want to call it canceling and use it as canceling, wonderful. But I'm still unhappy. All right, here we go. Last concern, danger. Danger. If I have 10 over 15, I know that this is 2 times 5 over 3 times 5, if I use the factors. All right, and the 5's reduce out, and I end up with 2/3. Right, now, some students that don't understand what they're doing here with the factors, they will say, well, 10, that's the same as 6 plus 4, and that is true. And they say 15, well, that's 6 plus 9, and that's true. All right, but then they try to reduce these out. All All right, you cannot reduce if you have operators in here. They must be multiplications. They must be factors. These are not factors. These are sums. All right, this looks like 1015 reduces to 4/9. Wrong, wrong, wrong. Wrong. Boo. Bad. As Trump would say, very bad. Very bad stuff. All right, so do not make sums out of this stuff. Strictly do factors. If you do sums, you're going to mess up and it's going to be terribly, terribly wrong. We cannot reduce sums. We have to reduce factors. All right, last part of section 3.5 is called the test for equality. Test for equality goes like this. It says, does 3/6 equal 2/3? And if you're not sure, put a question mark here. If you're not sure, you can do what's called the cross product. Cross product. Product test. Okay, and the cross product test says that I am going to multiply these two. I'm going to multiply these two, and do I get the same number? 3 times 3 is 9. 6 times 2 is 12. 9 and 12 are not equal, so these two are not equal. 3/6 is not equal to 2/3. All right, what about -6/8 and -9/12? Okay, so if you're not sure, what you do is you do the cross product. You take 12 times -6, which is -72. You take 8 times -9, -72. Since -72 is equal to -72, these two are equal. -6/8 is exactly the same as -9/12. And again, you could move the negative, it wouldn't make any difference. All right, so that is, we'll do one more example here. 6/7, is that the same as 7/8? Question mark. Well, 7 times 8 is 48. 7 times 7 is 49. 48, 49 are not the same. Therefore, these two are not equal. They're not the same value expression. Right, so that is 3.5. Okay, 3.6. Multiplying and simplifying. Okay, this is 3.6. Okay, if I want to multiply fractions, if I want to take 5/6 times 14/15. All right, now if you want to do the work, we know, if you take it 2/3 times 3/4, that is 2 times 3 is 6, 3 times 4 is 12, and 6 over this is 2 times 3, this is 3 times 4, and so you end up with 2/4, which reduces to 1/2, right? And that's easy with the small numbers, but when you get bigger numbers, you end up with something big here. 14 times 5 is 70. That's a big number. I don't like it. And 15 times 9 must be about 90.
You're out of focus.
I'm sorry?
You're out of focus again.
I'm out of focus again. Still out of focus. Okay, if I have to switch back cameras, well, okay, let's switch cameras and see if this thing will behave itself. Better?
Very good.
Okay, very better. All right, so here we go. We got 5/6 times 14 over 15, and that's just going to be big numbers to play with. and you're going to multiply them by hand most of the time. But if you leave these in factored form, this is going to be 5 times 14, which is 2 times 7, and 6 is 2 times 3, and 15 is 3 times 5. And now, when it's in factored form, it's very easy to reduce. You don't have to play with this at all. You can just say, well, these 5s reduce out, these 2s reduce out, and so I have 1 times 7 is 7, and 1 times 3 times 3 times 5 is, this is not a 5, this 5 reduced out, that's a 1. 1 times 3 times 3 times 1 is, 3 times 3 is 1 is 9, 7 ninths. Now, you could have, like I said, you could have done it the long way. 14 times 5 is 70. 6 times 15 is 90. And then you could, people will say, there's a 10 comes out. But that's going to be a lot more work than doing it the factoring way. In fact, is when they start doing this homework for section 3.6, I think they're going to ask you, what are the factors? So if you want to just go ahead and do this, it's going to say you're taking too much time, you're doing too much work. All right, here we go. 2/3 times 9/4. Now those numbers are not bad, but I'm going to leave it in factored form. I got 2 times 3 times 3, and I have 3 times 2 times 2, right? This is 9, and this is 4. So now I don't even have to do any reduction. The reduction's done for me. These 3s reduce out, these 2s reduce out, and I'm left with 3/2 of my answer. All right, I mean, if you multiplied it out, you would add 18 over 12, and then you would have had 18, which is that, and you would add 12, which is that. You just have to do more work. All right, let's do one more. I'm going to do 32 times 7/8. Now, I'm going to start off with an easier one. 10 over 21 times 14a over 15. 10 is 2 times 5. 14 is 2 times 7 times a. All over. 21 is 3 times 7. 15 is 3 times 5. And so now, what's reducing out here? A 5 is reducing out. 5 over 5, 1. 1s are reducing out. 5 over 5 turns to 1. 7 over 7 turns to 1. So I'm left with 2 times 1 times 2 times 1 times a, 4a. And I have 3 times 1 times 3 times 1, 9. And I'm done. Otherwise, you could have done this and got, what, 140a over, boy, that's a big number. I don't even want to do that work. You can do it with a calculator, but that's just a lot of work. You'd end up with this massive pile that you need to go back and do all the factor tree. So this is just a lot nicer if you can leave it in factored form, and then everything just automatically reduces. Okay, questions so far? We'll do one more. I'm going to do one more example. These examples are in the textbook. If you pop open the textbook and just look through their examples on 3.6, these are all in there. 32 times 7/8. All right, now 32 times 7/8. If I multiply a fraction, I need to make fractions, so I'm going to put the 1 underneath, turn it into a fraction. And so now I'm going to have 32, which is 2 times 16, which is 2 times 8, which is 2 times 2 times 2, times 7. 1, 2, 3, 4, 5, 2 to the 5th power is 32, good deal. And then on the bottom I have 1 times 2 times 2 times 2. All right, now it just reduces itself super quick. 2's, 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 I'm left with 2 times 2 times 7. 4 times 7 is 28, and I'm done. You mean you got 1 times 1 times 1, it's got a 1 underneath, but you can just take that off because they're equivalent. Any number over 1 is automatically the number. All right, we're going to do one application, maybe two applications here. for 3/6. All right, if I had 21 rose bushes, 21 rose bushes. All right, and I wanted to fertilize them. And the guy at the nursery says that you want to give each plant 2/3 pounds of, I don't know, what do they put on there? Like 333? Nitrogen, potassium, phosphorus. I would just call it fertilizer. We don't care about this. 2/3 pound of fertilizer that they sold to you. Okay, so I have 21 plants. Each plant gets 2/3 of a pound. How many pounds do I need to buy? All right, so I got what? I got 21 times 2/3 each. So I can multiply this and get 42 over 3 and then do the reduction, or I can just say this is 3 times 7 times 2, 21 times 2, and on the bottom I'm going to have 1 times 3. And the 3's are going to reduce out, and I'm going to have 1 times 7 times 2 is 14 over 1, or I just need 14 pounds of fertilizer to take care of my 21 plants. Each one gets 2/3 of a pound. Okay, so there's one application of multiplying fractions. One more example of multiplying fractions is when we use the triangle formula for area. Okay, if you have a triangle, I know that the area formula is 1/2 base times height, or it is base times height divided by 2. Since we're multiplying fractions, we're going to go ahead and use this one. If I have a triangle that is 9 yards here, and it has a altitude of 6 yards, I'm going to have 1/2 of 6 times 9 gives me 1/2 of 54. And so 54 over 2 reduces to 27. And again, since it's area is always two-dimensional, it would be yards squared. Okay, so that's a review of the triangle formula. Now let's do some with some actual fractions in it. We got ourselves just this ugly triangle. This is 10/3 inches, and the height is going to be 4, I'll make it centimeters, 4 centimeters. So the formula is 1/2 base 10/3 times height, which is 4 over 1. So we end up with 1/2. 10 is 2 times 5. 4 is 2 times 2. And I have 2 times 3 times 1. So what's going to reduce out here? Looks like a set of 2's is going to reduce out. And that's it. So I have 1 times 1 times 5 times 2 is 10 times 2 is 20. And 1 times 3 times 1 is 23 centimeters squared. All right. One more example of using the triangle formula. I don't know if this is in the homework, but it's certainly in the I think this is in the PowerPoint. If I have a kite, and the kite here is I'm going to call it 20 centimeters, and this is 16 centimeters. Can I find the area of this kite? Well, I can cut this in half And now I have a triangle that is 20 for its base and a height of 8. So formula 1/2 base. My base here is 20. 1/2 times the base times the height. What's the height? 8. So I have 1/2. 20 is 2 times 2 times 5, 4 times 5. And 8 is 2 times 2. And on the bottom, I just have a single 2. Reduce out 1, 2, and I have 10, 20, 40. I have 40 centimeters squared, but that is only half the kite. So if this is 40 centimeters squared for half the kite, I'm just going to double that. 80 centimeters squared for the whole kite. This is half the kite. The whole kite's this. All right, the last application I'm sure they are going to do for the homework is if you have what's called a pie chart, and I have $36,000 a year to live on, and I know that 1/4 of my income goes to food. So the question is, how much is that in dollars? Well, you got 36,000 times 1/4. And 36 divided by 4 is 9 with 3 zeros behind it. So this is $9,000 goes towards food. If I have another 1/4 that goes for taxes, I don't even have to do the work anymore. I know that 1/4 of 3,600 is 9,000. If I have 1/10 goes for clothing, 1/10 clothes, then how much goes for clothes? 36,000 times 1/10, right? Multiplication is often the same as of. 1/10 of my 36,000. 36 divided by 1 is going to be 3,600. So clothing, $3,600. And then they will do some more. They will do like 1/5 for housing. 1/5 housing. So 36,000 times 1/5. Now I need to take 36 divided by 5. Gives me 36,000. Divided by 5, 35 is 7. 1,000 is 200. So $7,200 is going to go for housing. So I think they might have to do some questions like that for homework, but I mean, you're multiplying whole numbers by fractions and ending up with values. Okay, that is 3.6. If there's no question, we will leap into 3.7. We've used 45 minutes, but that's fine. 3.7 is super short. (3.7) Reciprocals. Reciprocals and division. This is an E, and there's an I in there. Reciprocals and division. Okay, reciprocal means that if I multiply two things together and they equal 1, right? So if I have a fraction, if I have 4/7, when I get done multiplying by something, I want to end up with 1. So the reciprocal is you just flip it. You take the reciprocal. So I'm going to take this and go down here. I'm going to take this and go up here. And now I have 4 times 7 is 28, and 7 times 4 is 28. And I know that 28 over 28 is equal to 1. So reciprocal is you just take a number and you flip it to get the reciprocal. All right, so the reciprocal of 1/3 is 1 here, 3 here. 3 over 3 is 1. 3 over 3 is 1. Sometimes they don't feel good. How about negative 5/9 times equals 1? Well, the negative 5 come down here, the 9 goes up here, I get negative 45 over negative 45, and of course, anything over itself is automatically 1. Okay, what about A over B? Times what? Equals 1. Well, the reciprocal of A over B is B over A, because A times B is the same as B times A. Multiplication is commutative. So AB over BA, or the AB over AB is the same thing. Anything over itself is automatically 1. We certainly could reduce out these variables. All right, and if you have something ugly, minus M over N times what? Equals 1. Minus M down here, N up here, minus with the opposite of M times N, and the opposite of N over M. Negative over negative becomes positive, and M and MM are the same, so they will equal 1. Reciprocals, you just flip it. You know you have a reciprocal because if you multiply them together, you end up with the multiplicative identity, which is 1. Okay, so reciprocal. Multiply something by a reciprocal, you end up with 1. Now, from here, we do a division. If I take 10 divided by 2, okay, that's the same as 10 divided by 2. These are equivalent statements. So I can certainly take 3 divided by 1/2. If I'm going to divide or multiply by a fraction, I want to change it and have fraction and fraction. So this is going to become 3 over 1 divided by 1/2. Now, if we think about this, and just to verify that we know what we're doing, if I take if I take $3, and I take each dollar and break it into halves, all right, 50 cents each. If I have $3, I divide each dollar into halves, I'm going to have 6 piles left, all right? So, I mean, if you want to see it mechanically, if I have 3, and I take each 3 and I break it in half, I now have 6 pieces. So, the process for dividing fractions is what's called invert and multiply. Invert means give me the reciprocal and then multiply. So this has become 3 over 1. I leave the first part alone. I take the second one and I put the reciprocal of whatever this is, and I multiply. So I get 3 times 2 is 6. 6 over 1 is 6. So 3 divided in halves is going to be 6. Now let's do it with some fractions. 3/4 divide by 1/8. Now that is kind of hard. I'm just going to do this. I'm going to say change it into the multiplication. You leave the first fraction alone, you flip the second one, you take the reciprocal of the second one, and you multiply. 3 times 8 is 24. 4 times 1 is 4. 24 divided by 4, you can take that off your multiplication chart, or you can go ahead and factor it out, but 24 divided by 4 is 6. So 3/4 divided by 1/8 is 6. How about 5/6 divided by 2/3? Leave the first one alone, 5/6. Take the second one, give me the reciprocal. The process is called invert. Invert and then multiply. And so I end up with 15 over 12, which reduces to what? 3 times 5 over 3 times 4. 3 is reduced out, I end up with 5/4. We'll do a couple more of these quickly, and we'll be done with 3/7. I don't think we do any applications in 3/7. Okay, if I have 2a over 5 divide by 7, I'm going to turn this into a fraction. I have 2a over 5, flip the second one, and multiply. So I end up with 2a over 35. Feels ugly? That's life. Now sometimes they look bad. 7/10 divided by negative 14 over 15. Now, you want to impress people? Tell them that today in your homework you did complex fractions. All right, and all that means is you have fraction divided by fraction. All right, it sounds cool, complex fraction, but it's just the same as this. 7/10 divided by negative 14 over 15. You leave the first fraction alone, you flip the second one, and you multiply. Invert and multiply. And so I get 7 times 3 times 5 over 2 times 5 times 2 times 7, and I got to keep a negative somewhere. I'll keep it there. All right, what reduces out here? 5 reduces out, 7 reduces out, and I'm left with, got to keep the negative somewhere. Looks like I have a 3 and a 2 times 2, 3/4. 1, 1, 1, 1, 3/4. Negative top, bottom, or wherever. All right, that's 3/7. Division is super easy. It's the same as multiplication, except you take the second fraction and you flip it, invert it. Take the second fraction, second fraction, and you give the reciprocal of it. Okay, 3/8 is not bad. How much time we got? We got lots of time. We're in good shape. All right, 3/8. Problem solving. Okay, problem solving, or actually we're not problem solving, we're solving equations. Solving equations. Now, back in the old days, a chapter ago, if I had 5a equals 45, all right, we did this earlier when we were doing all integers. We'd say, this is 5 times a equals 45. I want to get a by itself, so I'm going to get rid of this times 5, and I would divide both sides by 5. All right, and then these 5s would reduce to 1, and I'd have a is equal to 9. And that's wonderful if you don't have any fractions anywhere. But we're going to make this problem ugly with fractions, and we're going to use division, or we're going to use the multiplication principle. So if I have 5a is equal to negative 7/3, you can certainly do it the old way. You can divide by 5, and you can divide by 5, and then this, of course, turns into negative 7/3 divide by 5 over 1, turn it into a fraction, and you can keep going. I'm going to show you a lot easier way. If I have 5a equals negative 7/3, I want to turn this into 1. Now I can turn it into 1 two ways. I can divide by 5, or I can multiply by its reciprocal, right? 5 over 1, the reciprocal is 1 over 5. And the multiplication property of equality says that I can multiply both sides by the same number, and I do not affect the validity of the equality. So the reciprocal of 5 is 1/5. I'm going to multiply both sides by 1/5. And 1 times 5 is 5. 5 times 1 is 5. 5 over 5. A equals negative 7/3 times 1/5. These 5s are going to reduce out, and I'm left with a. And over here I have minus 7 times 1 over 15. Now that was much, much, much less work than all of this. Right, so we're going to practice that. We're going to do this for a couple times so that you feel comfortable doing that. fact is, we're going to do some really ugly ones here. Let's do a simple example. This is example 1 on page 204 in your textbook. If I have 3/4 x is equal to 15, right? Now, you can divide both sides by 3/4 because you want to get rid of it times 3/4, or the goal is to change this into 1. If I multiply both sides by the reciprocal of the coefficient is that number in front of the variable. If I multiply both sides by the reciprocal of this thing, these 4's reduce out, these 3's reduce out, and I'm done to x equals 15 times 4 over 3 times 1. 15 is 3 times 5 times 4 over 3. These are going to reduce out, and I get 20. So if 3/4 of x is 15, then x is 20. And that makes sense. 3/4 of 20 is equal to 15. All right, we'll do a couple more of these. I'll leave that one there for now. Okay, this is example number 3 on page 205. This is page 205 in the textbook, example 3. Going to be different than your video, going to be different than the PowerPoint. 10/3 is equal to the opposite of 4/9 or -4/9 x. Right, so here I am. I got fractions on both sides. You can divide both sides by -4/9 and go through all that work, or you can just multiply by the reciprocal of this coefficient, this number in front. So I have 10/3. I'm going to multiply that by the reciprocal, which is what, 9/4, and a negative somewhere. And here I'm going to take -9/4 times -4/9 x. And then this -9 times -4 gives me 36. And this 4 times 9 gives me 36 over x. These 36's, 36 over 6 is 1. I'm left with x over here. And over here I have what? I have a negative somewhere. 3 times 3 times 2 times 5. Did I go blurry?
Yes. There you go. A little
Okay.
bit.
Let me see if that works. Otherwise, I will go ahead and switch cameras. Not too bad. Let me switch cameras back and forth. Usually when I switch the camera, it causes the focusing software to kick in. Is that better?
Very good.
Much
Yes.
better. Almost acceptable. All right. So I got what? 3 times 3 times 2 times 5 with a negative somewhere. I have 2 times 2 times 3 on the bottom. Over here, it'll all turn to 1 because I took the reciprocal. Reciprocals times each other turn into 1. And so what's going to reduce out here? A 2 is going to reduce out. A 3 is going to reduce out. And I'm left with a negative 3 times 5 is 15. And this is the 1, this is the 1, and 2. So x equals 15 halves. Am I off the screen here? All right, I don't want to mess the camera up. Okay, not too bad. All right, last example is going to be a story problem. Okay, now, if I had 5 pounds of sugar, and I was going to make some little cakes, and each little cake took 1/3 pound each cake. The question is, how many cakes am I going to make with 5 pounds? Well, if you think about it, if I take 5 pounds and I have a 1/3 pound scoop and I start scooping, I'm going to take 3 scoops for each pound. So by logic and by just thinking about it, I'm going to have 3 times 5, I'm going to have 15 cakes. And that works fine when you have these nice numbers. All right, now what did I do? I took 5 divided by 1/3, right, which is 5 over 1 divided by 1/3, which is 5 over 1. You leave the first one alone, you flip the second one, and you multiply. And 5 times 3 is, I got 15 cakes. And our logic told us that's the answer we should get. So the process is, if I have something that I'm going to divide into pieces, I can take that something and divide it by whatever size that piece is. So since everybody's getting vaccinated soon, if I have 60 milliliters, did I just go bad? It's pretty messed up, huh? I don't know, maybe it doesn't like me changing colors. That's too bad. Okay, so here we go. I got 60 milliliters of medicine. 60 milliliter bottle for like giving shots. All right, and each person gets 15 milliliters. So the question is, how many people can I vaccinate? Or how many people can I treat? How many treated per bottle? Okay, and it's the same as it was over here. I have a total of this, and I'm going to break it into these pieces. So I'm going to take 60 milliliters, and I'm going to divide it by 15/4. All right, and how am I going to do that? I'm going to take 60 over 1 divided by 15 over 4. When you divide the fraction, you leave the first one alone. You flip the second one, and you multiply. You invert and multiply. So now I have 60 times 4 over 1 over 15. 60, am I going to break that into pieces? Sure. 2 times 30, which is 2 times 15, which is 3 times 5, times 4, which is 2 times 2, all over 15, which is 3 times 5. How convenient was that? Did my camera just go bad again?
Yes.
There, better. All right, so 60 times 4, this is 60. 2 times 2 times 3 times 5 is 60 times 4 over 1 times 15, which is 3 times 5. The 3 is reduced, the 5 is reduced. I'm left with 2 times 2 is 4, times 2 is 8, times 2 is 16 people. So a 60 milliliter batch divided into 15/4 milliliters is going to give me 16 people will get treated. All right, or 16 doses, whatever you want to call it. All right, looks like she went out of focus again. We'll take 2 seconds to flip it. So we have that for notes. All right.
Yep.
So we still have 10 minutes, but that's fine. All right, so that is the notes for 3.5 through 3.8. Like I said, there's about an hour and a half of homework without the media. If you need the media, wonderful. I went through the media for 3.5, 3.6, and 3.7, and they are the PowerPoints and the videos are great. They do everything that I've done, and they use more professional, more precise vocabulary. Sometimes that vocabulary messes people up, and so I don't use it. But so anyway, the PowerPoints and the videos for these seem like they're just wonderful. Certainly try to get the homework 3, 5, 6, 7, and 8 done before class Wednesday. And then Wednesday morning, I'm assuming at midnight it opens up. And then Thursday at 10:59, she closes because the closure at least is on Eastern Standard Time. It may actually open up at 11 in the morning on Wednesday, 11 Tuesday night, it may. If everything's on Eastern Standard Time, it may be looking at that as midnight, because it's set up to go from midnight to first day to midnight second day. So that is lesson for 3, 5, 6, 7, and 8. I need to take roll. Let me download attendance. And then I need to go up and shut off this recorder. Stop recording. Unless people have questions. Anybody want to say something vulgar before I stop the recording?
No.